Hi all, let's do some first examples for using transformations to sketch the graph of a new function starting from some known graph of a function. So I'm providing you with the graph for now. This graph, this is function y equals f of x. It's a half circle. It's the bottom half of a circle that's centered at -3, 0 and has a radius of 2. And I want to sketch the graphs of several different things. So first, I want to sketch the graph of y equals f of x over 2. Okay, so what are you starting with is actually the easy question here. I'm starting with this half circle. And the next question should be, what transformations are you applying to this graph? So the equation should tell you this directly. The formula, I can see that my x's are now divided by 2. So because that's attached to my x, my input, and not my output, that's going to be horizontal. Remember, the horizontal are a little tricky. If you change your x, that automatically changes your y. So the question then becomes, to keep y the same, what do we have to do? And the answer is, to keep y the same, we would have to double all of our x's to cross this 2 out. So this is horizontal stretch by 2. Okay, so the graph is going to be twice as wide. You want to be really careful. I deliberately made this not touch the y-axis so that you could see this. Because this graph doesn't cross the y-axis, none of the points will stay fixed when we stretch. Not only is it going to be twice as wide, it's also points are going to be twice as far from the axis. So for example, the circle used to end at -5, 0. When I double my x's, that will be way out at -10, 0. So let's see if I can leave myself plenty of room in quadrant 3. 2, -2. -6, -8, -10. I'm not doing anything to the y values, so still just getting down to -2 should be plenty. Okay, so the point, -5, 0, when I double my x's, that point ends up at -10, 0. So there's kind of two things happening here. One is this big picture. I imagine taking this circle and stretching it twice as far away from the axis, stretching each point twice as far away. So it's going to be twice as wide. So it's actually going to be the bottom half of an ellipse. And all points will move, so it'll look a little further away from the axis as well. So I already have a pretty good picture in my head, and then I want to snag a few key points to make sure I get the details right. So another really good point to follow, so I use -5, 0, is -3, -2. Okay, so if I start at -3, -2, and I double my x-coordinate, I'll land at -6, -2. This was the bottom of my circle, and it will be the bottom of this new shape as well. So it's going to be elliptical now since it's getting stretched out a little bit, but it's still going to be the bottom point. Last really nice easy point that I would make sure I followed is the other end point, -1, 0. If I double my x, that'll end up at -2, 0. So now I already pictured this half ellipse. I've got some of the details. I know the endpoints. I know where the bottom is, and I just do my best to connect the dots. It's really important that your new function looks related to your old function. I'm taking a shape and modifying it in some ways, but it shouldn't look like a completely new shape. You shouldn't have a bunch of weird wobbles going on here. It should still look like this kind of half round, just stretched out a little bit. Okay, so that was horizontal stretch. The next one I have on my list is y equals f of x minus 2 plus 4. I'll tear this off so you can see what I'm doing. Okay, so I'm starting with the exact same thing. First thing to notice is this f of x is extremely important. If you just disregard this, you're not going to know what function to apply the transformations to. So the first thing I spot here is, okay, I need to start with function f of x. That's this one right here, half circle. The next thing I spot is that the -2 and the +4 are not part of the formula for function y equals f of x, so they are my transformations. If I subtract 2 from my x's, again, changing your x's changes your y's, so I actually have to increase all my x's by 2 to get the same y value, so this is a shift right 2. And then adding 4 to your y values really does exactly that. It doesn't do anything to your x values, so I have a shift up 4 as well. So shifting is what's called a rigid transformation. It won't change the shape of this at all. It'll still be a perfect half circle, radius 2. It's just moving it over 2, up 4. So let's see. I'm expecting it to go a little ways up here. Okay, so I'm going to give myself room in quadrants 1 and 2. Should be more than enough room. Okay, so now we can do the point by point. So in my head, I have this picture of the circle moved over 2, up 4, still looking like a half circle, but sitting up above the axis now, the x-axis. And I'm going to follow point by point my 3 key points that I've labeled. So if I start with -1, 0, and I move to the right 2 and up 4, feel free to keep these separate. But I would say something like that, a pair of shifts, is a really easy pair to do all in one step. So if you prefer, you can pick the graph up and move it over 2, draw that, and then pick it up, move it up 4, draw that. But 2 shifts are generally fairly easy to keep track of. Okay, so 1, 4 ends up being a new endpoint. The bottom of the circle was at -3, -2. If I move to the right 2 and then up 1, 2, 3, 4, the bottom of the circle should now be at -1, 2. The left endpoint of my circle was at -5, 0. If I move to the right 2 and then up 1, 2, 3, 4, the left end of my circle should now be at -3, 4. So it's still the bottom half of a circle with radius 2. I make sure it still looks like the bottom half of a circle with radius 2. And that is my sketch for part B. Okay, one more and then we'll just refresh a little bit with the idea of odd. So my last one that I have here is sketch y equals 3 times f of -x. Okay, so once again, the first thing that jumps out at me is that this says to do something to function f. So I go looking for function f. Is it an equation? Is it a graph? Is it a table? Here it's an equation. I'm sorry, here it's a graph. So here's my graph, half circle. The 3 is not in the plain old f of x function that I started with, and the negative sign is also not there. So those are my 2 transformations. If I multiply the entire function by 3, that's my y value. So that's vertical stretch by 3. The negative sign is applying to my x's, so it's going to take all my negative x's and switch them to being positive. All my positive x's are going to switch to being negative, so that's a flip over the y-axis. Flip or reflect. Reflect is a good transformation word as well. Flip over the y-axis. So if your x's flip, it's over the y-axis. Okay, so I'm picturing this thing being 3 times as tall. Since all of the y values are negative, there's going to be even more negative. So it's going to be 3 times as tall. And then it's flipped across this way. So I expect it to end up in quadrant 4 if I flip horizontally. So I'm going to give myself some good room in quadrant 4. Okay, so starting with my endpoint, -1, 0. Again, if you prefer, you can do these separately, but I think this is another pair that's fairly nice to do. I think it's a little trickier to combine flips and shifts, or stretches, compressions, and shifts, so I tend to keep those separate, but I think it's actually not too bad to combine a vertical stretch with a flip, especially since some of our points aren't going to move when we do the vertical stretch. So flipped across, stretched out, I'm picturing it over here. if I take the point -1, 0, and I flip it across the y-axis, it's going to end up at 1, 0. If I then do vertical stretch by a factor of 3, because I'm stretching away from the axis, that point actually won't move because it's on the x-axis, so it stays put. The bottom of the circle was at -3, -2. When I flip across, that will end up at 3, -2, and then when I do vertical stretch, that'll move down to 3, -6. So the bottom of my circle, it's going to be an ellipse now since it's stretched out, is way down here at the bottom. And then my last key point was -5, 0, so it's sitting out here somewhere. When I flip across, it ends up at 5, 0, and then when I do vertical stretch, multiply my y by 3, 3 times 0 is still 0. So the endpoints move to +1 and +5, and the bottom of the circle is stretched all the way down to -6, making it an ellipse. It would be completely fine here to, what did I do? I flipped and then stretched. To stretch and then flip, that shouldn't make any difference. The only order rule that you need to be aware of, and this will come up in later parts of your homework and later examples, is you should shift last. If you always do your shifting last, it'll save you from potentially getting in some trouble. Okay, very last part of this one. I am going to add a little bit to the graph of f to create a new function that is odd. So f is definitely not odd. Odd requires symmetry through the origin, and I don't see that. I can make it odd by adding some stuff in quadrant 1. So again, you can picture this 180-degree rotation, or you can picture flip over the x-axis, flip over the y-axis. Whatever's working for you is fine with me. So if I picture either way, I know I'm expecting to get half circle over here in quadrant 1, and then just to be really careful, I can follow my points. So if I take -1, 0, and I flip it across the x-axis, it actually doesn't move because it's on the x-axis, but when I flip it across y, it lands over here. The bottom of the circle, -3, -2, when I flip it across the x-axis, it ends up at -3, 2, and then across the y, it ends up at +3, +2. And then -5, 0, again, doesn't move when I flip across the x-axis. When I flip across the y-axis, it ends up at 5, 0. So my new function is actually made up of two pieces, a half circle in quadrant 3 and a half circle in quadrant 1. So all of that put together creates a single odd function. I'm not looking at it as two separate functions. I'm looking at this as a single function that has odd symmetry. All right, that's it for that one. Thank you for watching.